What's up, everybody? I am not a software engineer, and I wanted to revisit one of my videos. It's about 2 years old at this point because there's been a lot going on in the world of cryptocurrency, hardware wallets, seed phrases, and things of that nature, right? So this video is kind of I don't want to call it a joke video, but it was basically saying we can brute force MetaMask seed phrases using Python. And there's a lot of kind of clickbaity, stuff going on with the title, and in reality, I mean, the odds of you actually brute forcing a seed phrase with Python are pretty much zero. And I wanted to talk about that a little bit more, and also talk about the security of generating your own seed phrase for use with a hardware wallet. So we're going to talk about something that I found on a specific hardware wallet called Bitbox02. Now, this is not an endorsement for Bitbox02, but I thought it was really cool that they actually publicize a method that you can use to generate your own recovery phrase. So I'm going to talk about that a little bit, and basically they walk you through it, right? You take some dice here that are casino grade dice, and you roll them in a way that maps to this lookup table. So for example, if you roll a 1, 1, 1, 1, that basically puts you in this row here. And then you have your fifth row, which will determine which column. So let's say it's another 1. And then you roll or flip a heads. That basically equates to a roll of 1, 1, 1, 1, 1 heads, which gives you the very first word here. Now, if you wanted to do this manually, and I've actually tested this myself with dice, it takes about 5 to 10 minutes because inevitably you will get a roll of a 5 or a 6, and we basically are saying the only time that's acceptable is on the 6th roll. So for a 24-word passphrase, and we're actually only going to roll the first 23, we'll talk about that in a moment, but for an actual roll of 23 words, you're going to basically take, like I said, 5 to 10 minutes, and you might be thinking, hey, I bet I could automate this and make it take a whole lot less time. And that is true. We can actually do that with Python, and that is the entire premise of this video. But before we get started with the actual Python implementation of the Bitbox dice rolling, and I don't know if they invented this, but they did publicize it, and it is really cool. So I totally recommend taking a look at this if you perhaps want to roll your own seed phrase. But I'm going to go ahead and look at a quote from the Mastering Ethereum book, which I'm actually reading through right now, and it is very good. That is not to say that I am solely focused on Ethereum, but it is just saying that I think this book has a whole lot for anyone who is interested in cryptography or cryptocurrency in general. But I'm going to go ahead and take a look at this really quick. There's a chapter called Cryptography, and there's a very important quote that I wanted to share with you. And basically, I can find that by searching for "do not," right? Okay, so there's a warning right here that basically says don't do what I'm about to spend the next part of the video doing, or the remainder of the video doing, but do not write your own code to create a random number or use a simple random number generator offered by your programming language. Right, so in many cases, and I believe in the case of my video here, that would be the random library, which is present and implemented differently in a variety of different programming languages, but is not cryptographically secure as a means of generating random. Right, so it does go on to say, it is vital that you use a cryptographically secure pseudo-random number generator such as CSPRNG. So I did a little bit of research, and you can actually use the Python secrets library. And so in the actual source code for secrets.py, you can go ahead and see PEP 506. I don't actually know what PEP stands for, but you can go ahead and look at this, and it looks like it does leverage a limited interface to the system CSPRNG, and I believe it's by way of random.system_random. So I would venture to guess that this is sufficient as compared to Python random. So we're just going to use secrets from the Python library. But moving on, I'm going to go ahead and start setting up where we're going to do this implementation of our dice rolling script/simulation. And in order to do that, I'm going to create a new directory, and I am just going to call that random seed phrase. And yeah, then I'm going to go ahead and cd into that, cd random seed phrase, and then I'm going to create a new file called roll.py. So touch roll.py. And there's a couple things I need here. One, you see that this list has all of the BIP39 English words, right? So I actually need to download that. So I can go here to the actual Bitcoin BIPs repo and then BIP0039 English.txt, and I'll go ahead and download the raw by just doing a simple wget into this directory, wget right here. And so I see that English.txt is there. And then lastly, I do want a copy of, actually I guess I don't need a copy of this. I can just keep it open in a tab. So I think that these files are sufficient. And now I can go ahead and just open up VS Code. Okay, so the first thing that we want to do is actually come up with a list of our BIP39 words, right? And the way that I'm going to do that is create a new empty list called BIP39. And then I'm basically just going to open that with open. And then we'll say english.txt as f for line and f bip39.append line.strip. So this should give us a giant list of 2048 words. That's the total number of BIP39 English words, and I think it doesn't matter what the language is, it should be 2048 words. So I can actually verify that by printing the length of BIP39. Then we can go back to our terminal. And just as a reminder, I use Windows Subsystem for Linux, basically for all of my stuff that does not require like a user interface or something like that, or my GPU, right? So right now I'm using WSL. I can clear this out and just use Python 3 roll.py, and it prints out the length of our list, which is 2048. So that is correct. And I can actually just print out the list if I want, although we already know what it looks like. It's just a giant list of all these words, starting from abandon and ending at zoo. So let's see if I can get back to where I was here. All right. And now we're going to get rid of this print statement because we do not need it. What we would like to do is create a function that will basically do what we have listed here, right? And again, I'm basically kind of jumping forward, but I've read the instructions here and I'm paraphrasing them for you. Now we're not actually connecting to a wallet, we're just creating our seed phrase using this, this methodology here for the dice roll. But basically what I need to do is roll the dice 4 times, and then after the 4th time, I will roll it a 5th time to determine which column I look in, and then basically the 6th time we'll just have, if it's a dice roll of 1, 2, or 3, it'll be heads, and 4, 5, or 6, it'll be tails. So I guess technically I am going to create a list, and that list is going to be called output. So I can go back to VS Code. We're just going to roll basically a number 1 through 4. And so I'm going to do that with a function called roll, def roll. And here we're going to have output, which is just going to be a blank list for now. And then I'm going to say while the length of output is less than 5, we're going to have a variable called cur roll equals secrets.rand below 6. So this means any digit below 6, right? And I think that is inclusive of 6. Actually, no, it's not. Okay, so I also do need to import secrets. So import secrets. So this will be 0 through 5, right? And then I want it to actually be 1 through 6. So I need to add 1, right? So this is effectively a range of 1 through 6. All right, so now I need to check to see, remember, we only want to accept rolls that are 1, 2, 3, or 4. And we want to re-roll if they are 5 or 6. So basically I just need a simple if statement. If cur roll is less than 5, output.append the string value of cur roll. Right, so this is going to increment our length of output. So as long as we have something that is under 5, output will be appended to, and thus this will get closer to our exit value of 5, right? And so what we want to do at this point, after our while statement completes, is just output dot append the coin flip value, right? So there's going to be, on the when output is equal to 4, this is still going to happen. We're going to add our 5th value here, and then the output length is going to be to this roll here, which means we'll know which column we're in. And so the last thing that we need to do is just choose between heads or tails. And we can do that with secrets.choice heads or tails. Now you might be asking yourself, okay, well there's 3 options that are equal to heads and 3 options that are equal to tails. Well, that's a 50-50 chance, and so I think it's sufficient to just use a secrets.choice, which again is going to be in this output.append secrets.choice, and the list will just be heads, tails. And that's going to be the same thing as having a choice between either the 1, 2, 3 or the 4, 5, 6. So then we can just do return output, and we can basically see what that looks like by just calling the roll function. So print roll, and let's see what that looks like. Great, so we have essentially our valid roll 4, 4, 2, 1, 2. So let's go ahead and see what this is by going back to our lookup table. So the first is a 4, right, which means we need to go to the page that starts with 4, and we have here, so we know that our first roll is a 4. And then we have another 4, so we'll go all the way down here. So 4, 4, 2, 1, right? 4, 4, 2, 1. 4, 4, 2, 1. And then the column the column is number 2. So 4, 4, 2, 1. This is 2. Right, so you can see how this is actually kind of difficult to do manually. But 4, 4, 2, 1, 2. So we have either heads, violin, or virtual, which is tails, right? And we have a head. So the number that we have mapped to is violin. And so if we're doing and again, the 24th word is going to be a checksum. We'll talk about that later. But if we're doing 4, 4, 2, 1, 2 heads, which is what we have, 4, 4, 2, 1, 2 heads, that is 1/23 of our list. So at this point, we basically just write down the word violin, and we'd go ahead and roll this again. So this would be our next word. As you can see, there's no 5s or 6s, right? We're just going to go ahead and run this a bunch of times and make sure we don't have any 5 or 6s. And I think that is right. So I've actually gone through this, and that's probably more than an entire seed phrase worth of words. But as you can see, it's quite a bit cumbersome and not much different than just rolling the dice and then doing this yourself. The only thing this makes a lot easier is this right here is essentially 5 dice rolls in a coin flip. And even that is quite a good decrease in the time that it takes to do this, but that again is only 1 word. So what we would want to do is map this and then do it 22 more times, right? And that's essentially what we're going to do with our script. So I'm going to clear this out. And we're going to go ahead and go back to VS Code. And at this point, we can get rid of this print roll statement, and we need to create a new function, and that's just going to be called 23 words. So def 23 words. And I know that's kind of a verbose name, but if we wanted to add a comment that explains it, we can go ahead and do that here. Generate first 23 words of a seed phrase in return, and BIP39, the 21st word, is a pseudo checksum. So we're just doing the 23, right? And so that's just going to give us a list called seed phrase, and that will be blank at first. And what I'm going to do now is for x in range 23, we're going to get a roll, word roll, and that's just going to be equal to a function call of roll, right? And what we would like to do, and you might be asking yourself, what couldn't you just do this? Well, we could actually do this. And we could just add it to seed phrase, right? So I'll do that now. Seed phrase dot append, and then we'll do word roll. And you'll see what this looks like when I output, or return seed phrase, right? And then I just call this print 23 words. So we'll go back to our terminal. And this is pretty hard to read, right? But it essentially, and we could do the length of this, right? Just to see how many words it is and verify that it's 23. It is 23. So now what we have to do is essentially map this to a word, this to a word, so on and so forth until we have our 23 words. But we also are going to need a question mark at the very end because we're going to come up with our pseudo checksum. And so really at the end of this, I need to do something here, right? Seed phrase. Actually, no, what I will do is I will create a new variable within my actual script, and this might be a little confusing, but that's fine. Seed phrase, and again, this is outside of my function. This is just a variable that I have, and that's going to be equal to a call of 23 words. And then at that point, I can just append seed phrase dot append, and really it doesn't matter if I do this here within the function. It might make more sense to do it in the function, but in any case, yeah, no, I think it's a little bit more elegant to do it within the function. So we'll go ahead and go through our, for x in range 23, we'll do our word roll, we'll add it, and then right before we return it, we will add this, seed phrase.append, return seed phrase. So then we have this here, and I can print seed phrase, and that should be a little bit more obvious. Yeah, so we have this last value, which is going to be a checksum, which is just a placeholder for now as a question mark. All right. So what we have not implemented is the ability to actually map one of these to a word, right? And so that's kind of what we need to do right now. And I'm going to do that by basically taking a look at the first 4 to determine which row that I need to look at. So if we go back here, and for example, let's just use 3111. If that is our first 4, then we know that we have essentially narrowed our search down to these words. And when thinking about the proper data structure to do this lookup with, there's probably some debate on what makes the most sense, but for me, I did the math on how many rows there actually are. And I think there's like 64 per page, which gives us a total of 256, which for me seems reasonable to use a dictionary with 256 key values, right? That means that if we looked up the number of keys in our dictionary, it would be 256, and each one of those would have a list of 8 items as their corresponding value. And so what we're going to do is build that now. So I'm going to go back over to VS Code, and I'm going to have a little variable up here called start IDX, and that's just going to be set to 0 at first. I'm also going to have a key num set to 1111, which is essentially going to be the very first key. And then after that, I'm going to create the blank dictionary called bipdict equals, and then we'll just have blank dictionary there. And so I guess I can do this. It probably has to be based on the BIP39 list, right? So I should do that after I create that list and before my function declarations. I don't really think it matters a whole lot. It's going to be nested for loops, and it's not the prettiest thing in the world, but it did work just fine. So for I in range 1, 5, and we're basically going to do this over and over and over again. Because again, the roll options are 1111, 1112, 1113, so on and so forth, up until a max value of 4 for each of those, I guess, integers in that 4-digit roll, if you will. So I know that wasn't the greatest way of explaining it, but it'll make sense in just a moment. For J in range 1, 5, for K in range 1, 5, for L in range 1, 5. And then basically what we're going to do is create a key at bipdict, and that's just going to be an F string, which is going to take I, J, K, and L. All right, so for the very first one, it'll be 1111. We're creating a, and that is essentially just key num. Actually, now that I think about it, we might not even need key num. I'm going to delete this and see if it still works. But yeah, so I'm going to basically set this equal to our BIP39 list, BIP39, at a start index of start index, right, which is currently 0. And then we're going to end at start index plus 8, start IDX plus 8, and this needs to be in parentheses. And remember that there's 8 per row, right? So we're basically, if we take a look at English.txt, this is going to look like 1, 2, 3, 4, 5, 6, 7, 8. So if we have a 1, 1, 1, 1, our key is going to be equal to 1, 1, 1, 1. And then our value is going to be equal to a list that starts at index 0, right? And again, this is basically, we're adding this to a list. So abandon will be at index 0. And then we're going to have abstract at 0 plus 8, and that is not inclusive, so it will only be through index 7, and that will be our value at 1, 1, 1, 1. So then at that point, we will add 8 to start IDX. And let's just take a look at what that looks like by printing it. Print bip dict. All right, so this is going to be super hard to read, but we can at least scroll up to the top and see that 1111 is in fact equal to abandon, ability, able, about, above, absent, absorb, and abstract. So let's verify that by looking at the very first row, and we see that it does in fact end at abstract. And so we can pick out another random one just to make sure. We'll try, let's try 2421. How about that? 2421. So we'll go back over here to 2421. 242. That should be right here. 2421. Should start with inject and end with insane. 2421. Inject. Insane. All right, so we're looking good. And honestly, we should check several more than these, including the very last one. So I'll just jump to the last one and pretend that I checked several more. But so for 4, 4, 4, 4, we should have yellow and end at zoo. So we'll go back to the very bottom. So for 4, 4, 4, 4, we do in fact start with yellow and end with zoo. So at this point, we haven't actually picked out. So we've done this part, right? We've done this like, okay, we can say for the first 4 digits, we can basically just look up against that dictionary the row that we start at. But then we need some logic that says, okay, which column are we at? And remember, there's 2 options in each column, and then we choose based on whatever the heads, tails value is. So there's still a little bit more work that needs to be done here. And let's jump back into VS Code. Okay, so we're actually going to do the mapping in our 23 words function. Seems like a good place to do that. What we need to do is get the first 4 dice rolls in string format so we can basically look up against the dictionary, because that's going to be how we start to dial in on the actual word, right? So I'm going to have a comment that has the format in which we do this because it is quite helpful. And we're going to do that right after we get our word roll, which again happens in this for loop here. So after we get word roll equals roll, I'm going to get the first 4 dice rolls in string format, and you do that like this. And so that's going to be first 4, and we'll just have that here. And this needs to be word roll, so we'll change that. And we do need a parentheses here. So at that point, we know our word row, right? And that's just going to be equal to word row. And we're going to say BIP dictionary, and the key is going to be first 4. And that will give us basically a variable called word row with, you know, this as its value, which is just that list, right? So then we need to continue to move further because we're trying to dial down on an individual word. And the way that we're going to do that is to create something called slice row, and that's just going to be equal to the integer value of word roll at index 4, right, which is really just the 5th roll. And I do need to subtract a 1 here in order to adhere to the 0 indexing of our sublist that we're going to create. So you're going to see what I mean there in just a second. But before we do that, we also need our coin flip, which is going to be equal to word roll at index 5, which is also just the last index. You could do a -1 here if you wanted. But basically what we're going to do is we're going to change our word row to a nested list with two elements each, right? And so what I mean by that is that this is going to be the 0 index, or our roll if our roll value is 1, right? And then conversely, this will be our 1 index or our roll of 2, our 2 index or our roll of 3, our 3 index or our roll of 4. And the way that we're going to do that is basically to change word row to nested list with 2 elements each, as I mentioned, and that's just going to change the value of word row to a list word row I with I plus 2 as kind of the last value there, or rather the range there, and then we're going to have for I in range 0, and then the length of word row. And our step is going to be 2. And this will make sense in just a moment. But then we're going to have a word choice variable set to word row, slice row, at index 0 if coin flip is equal to heads. And then we're going to have an else statement, else word row, slice row, at index 1. So this basically determines which of the choices we're going to do. Heads being index 0, tails being index 1. And we're going to use that slice row, and again, this is 0 indexed, right, to figure out which of these sublists we're going to choose from. So now at this point, and again, it's kind of arbitrary until you see it, but we can just take the word choice and append it to the seed phrase. So seed phrase dot append word choice. And it might make sense to print this, right? Our word row, and it changes. Word, we'll just print that. Print word row. And I'm going to see what happens if we just run this here. Oh, this should not be here. It should just be word roll up until index 4. That is not a function. Okay, let me go back here and take this out. Try that again. Okay, so we got a whole lot going on here. I'm not going to try to make sense of it, but I did want to show you that basically that word row that we create breaks this down into columns, right? And as I mentioned, it's 0 index, so we have 0, 1, 2, 3, which if we add 1, then we kind of get the rows, or columns rather, that we're looking at, which would be a row of 1, 2, 3, or 4. And then we make our choice based on the 5th roll, right? So if the 5th roll is, for example, a 1, 0 indexed, then our choices would be between sword and symbol, which again would be heads or tails. And I wasn't expecting this to print out this way. I'm kind of interested to see why it did. I think it's because we actually appended the word. Let's see. Let's go back. Oh, okay. So I'm appending 2 things: the word choice and the word roll. Now this is probably good for debugging, because I can see that gift is the word that we got when I had a roll of 2, 3, 1, 2, 4 heads. So we can double check to see if that's correct by looking at 2, 3, 1, 2. 2, 3, 1, 2. 2, 3, 1, 2, right? Which gives us this. So that should be our first thing to look at. It should be genre through giggle. Genre through giggle it is, right? And then 4 would be these two, gift and giggle, which is correct, gift and giggle. And then lastly, heads gives us gift, which is actually the word that we got. So that was somewhat helpful in printing both of these. But what we can do now is not actually print the roll. We can just print the word choice and then append that question mark, and we should actually have our seed phrase. So let's go ahead and make sure there's no other, we can print, we can get rid of that, clear this out. And we're still printing the dictionary. We don't need to do that. So we'll remove the print statement up here. And we should just get a 23-word seed phrase. And there we go. So we are getting close to being done, but you'll notice that there's still that question mark here at the end. And this is basically where I had to do a little bit of research because I didn't know how that checksum was created. I didn't know the logic behind it, and I wouldn't have known which word to choose until, like I said, I did some research. So if you were one of the several people that mentioned that this was a checksum, thank you. And I found 2 blog posts. They're both on the Blockplate website, and I think Blockplate makes, I guess, physical backup plates for seed words, which is kind of a cool thing. But I'm going to link both of these because they're fantastic, and then there's also like something that will determine whether or not this is real. So what I can do, and we'll use this in a moment just to verify their checksums are correct. But I did want to basically say, at this point on, I am leveraging logic that I found in this blog post because it was already created, and I thought that it was quite elegant. So from this point on, when we're doing the checksum, I am borrowing heavily from Blockplate. So thank you to whoever wrote this. It's really, really helpful. But we're going to go back to VS Code, and we're basically going to come up with the last word. At that point, we will no longer have this ugly question mark. We'll actually have a last word. So I did want to mention that essentially it is going to be another BIP39 word. So our seed phrase index is going to be equal to the index of our word if it does not equal the question mark, right? And at this point, we can print this out, print seed phrase index. We'll generate a new seed phrase. By the way, every time I run this, I'm effectively starting with a new seed phrase, right? We're never using the same seed phrase because it's generating a random one using secrets module in Python. So you have to keep that in mind. Every single time it's a new seed phrase. Do not expect this to ever show the same output when we print the seed phrase. It's mathematically impossible. But when I do that, we get another seed phrase, and it basically gives us the index of the BIP39 word, right? So if we were to go, and I believe, I can't remember if this is based on the, it should be 0 index, right? So if we looked up the word Latin, for example, if I go back to roll.py and then english.txt and control F Latin, it's going to say 1004 because this starts at index 1 and is not 0 index. But that is correct. It should be 1003 in our Python list, and it is, as you can see here, 1003. So that is correct. Now we can go ahead and move on, and we can basically say we're going to calculate the number of bits missing for entropy. I'm going to remove this and paste this in, and now we can print this, and we'll take a look at what that looks like. And so we see that there's 3 bits of missing entropy, and so at that point we'll go ahead and calculate all the possible permutations of missing bits for entropy. And I'm skipping out on a really great blog post here, but let's just go ahead and say calculates all. So if you want to go through and read this just to see the logic, I would highly recommend it. It helped me understand this a whole lot more. But yeah, I'm going to go ahead and just copy this in. And actually, my variable names are a little bit different. So it would probably break things if I did that. But I'm going to go ahead and paste this in here. And so now, if we're working through this, we'll get all the permutation of missing bits for entropy. So if you want to see what that looks like I said, we can just print this. So this starts to look like indices for BIP39 words. Now, that is not what it is just yet, but it will be shortly, right? And we can do that kind of the next part of the blog post by pasting this in here. And now we need to import hashlib. And I don't actually have my seed phrase binary yet, so let me add that up here. And this basically says, and I forgot to print this just to show you, but I will do that in a second. We're going to import hashlib. And this, just to show you what this looks like, print seed phrase binary. So you can see what my seed phrase looks like in binary. But we've already kind of moved past that, so I'll get rid of it. So at this point, inputs each entropy possible in the SHA-256 function to result in corresponding checksum. Let's print that to see what it looks like. So this is starting to get closer to what we need, right? And basically that's the whole point of this. So we're going to come up with our last word at this point, and I will do that here. These are the possible last words. So, just to show you what this looks like, I can take this right here and I can put it, well, what I should do is I should print this out as a string, right? Because if I paste this into the, I guess it was that website here, if I paste it in like a Python list, it's going to break. It's just not going to work. Utility not in word listed, you mean utility. Yeah, exactly. So what I need to do is I need to go back and print this in a more elegant way by, so I think that variable is just called seed phrase. So I can print, actually I need a space, join seed phrase up until the last index, right? So seed phrase up until -1. And I think that will look better, and it does. So now I can paste this in. We're missing one word, and so it's saying invalid mnemonic, right? But we know, due to the code that we implemented from the blog post, that it can be any of these 8 words. So that is basically implying if I copy noodle and I paste it as the last word, it will be a valid mnemonic. And there you go. We have just used the Python secrets module to generate a cryptographically random seed phrase. And then we have leveraged the checksum functionality to come up with our 24th word. And we have validated that here as an actual valid mnemonic for a Bitcoin address. So you can see a whole bunch more info here, including like addresses and the derivation path and like all that stuff, which is way beyond. You can see private keys, public keys, yada, yada, yada. So don't use this. Please don't use this as a wallet unless you want everything to get stolen. But you can see that we were able to generate this using Python, basically using the exact same logic that the Bitbox Diceware manual explains how to do. So I did want to end the video by actually showing what this looks like if you do it with physical dice. I'm going to go ahead and log off my computer and show you what that looks like, just to see that it is possible. And if I were to do this, and if anyone were to recommend you a choice between doing this with our Python script, which is basically just this, right? Or doing it with dice, I'm sure that there would be some debate on which one is more secure. Personally, I think the one that is more secure is the one that is further away from a computer that may be compromised. And in that case, it's probably the dice, right? Now that is assuming, well, I'm sure there is someone out there that could prove mathematically that using the secrets module in Python is definitely more of a secure use of random number generation than a human rolling dice. Actually, I'm almost 100% positive that that is the mathematical truth of the matter. However, the fact is, if you're running this on a computer, that is a risk because your computer may be compromised. Someone may be monitoring everything that shows up on your display. And in that case, if you ran this script and you basically got this and you decided that this is going to be your seed phrase, and even if you had your 8 checksum words listed here, they'd know that your first 23 are this, and then, you know, they basically steal your funds that way. So if you assume that your computer is compromised, you should never generate your random seed phrase on it. You should absolutely use the dice. And if you want to be fully offline when coming up with your seed phrase, you should use the dice. Let's take a quick look on what that looks like. All right, let's try this out. I'm going to go ahead and roll 4 dice. And so we have a 3, a 5, a 3, and a 4. That means the second one needs to be re-rolled. And now we have a 1. So that's a 3, 1, 3, 4, which is actually valid. And we can take a look. Let's see, 3, 1, 3, 4. So that means this is the row that we basically can work from. So now I can go ahead and roll my 5th roll. And that gives us a 1, which means we are in column 1. So that means we need to flip a coin between mention and menu. Now I can either use a coin or I can roll the dice again. I'm just going to go ahead and flip a coin because I have one. And it is actually heads, which means that we go with the word mention. So if you're keeping track of time, that did take considerably longer than our Python script, and I still need to do this 23 more times, or rather 22 more times, and then come up with the checksum. So yeah, obviously this is a lot more time consuming, but the benefit is that it is fully offline, other than the fact that I've recorded this and put it on YouTube. But you get the idea. If I were actually rolling my own seed phrase with dice versus coming up with a Python script on my computer, which may or may not be compromised, I think I'm going with the dice, even though it is much more time consuming. So with that said, ultimately the choice is up to you. Please do not use my Python script on a computer that is compromised and then, you know, put your life savings in there. I would feel really bad if this was in fact a vulnerable script. But I thought it was a cool way to actually implement a physical way of rolling dice and thus coming up with your own valid seed phrase for use with crypto. If you have any questions, please leave them in the comments below and I will do my best to get back to them. Thank you so much for watching, and I'll see you in the next one.